This video is part of an online course of Calculus 1, and I'm going to talk about algebraic functions as a class of essential functions. Okay, so what is the algebraic function? A function f that can be constructed using basically algebraic operations like adding, subtracting, multiplication, division, and through starting with a polynomial. Starting with polynomials. So we have our nice functions, polynomials. If we add the polynomials together, if we subtract them, if we multiply them together, if we divide them, then we get algebraic functions. Okay? Let me give you a note. Is that for the domain, we need to watch out for all x such that f of x makes sense. Well, what do I mean by that? I mean, for example, if we add them together, two polynomials, no problem. If we subtract them or if we have a product of them, no problem. But if we have a polynomial on top and if we have another polynomial on the denominator, then denominator cannot be 0. If we have a polynomial or basically a function inside a root and then n is even, f should be greater than or equal to 0 if n is even. Okay, I talked about power functions on the previous video. Okay, so make sure that you check that out. Let me give you one example. Let f of x to be the fraction x cubed minus 16x over x minus 1 plus square root of x plus 3. What is the domain of this function? Okay, for the domain, I see that I have a fraction in here, so the denominator, whatever that I have on the denominator, cannot be 0. And based on that, x cannot be equal to 1. Very good. What else? Then I see that I have a square root of x, which means that basically x should be greater than or equal to 0. So we have two criteria that we need to watch out. One of them is that x cannot be 0, then x cannot be a negative real numbers. So the domain based on these two looks like this. If this is real numbers, if this is 0, 1, 2, 3, I can put all these numbers that are positive based on here. For my domain, I can put everything that I have in here, including the 0, as you see, but I cannot put 1 in there. So I'm gonna exclude 1, and then this is the domain of this function. If I want to describe it, I can say that D is all real numbers such that x is greater than or equal to 0 and x cannot be equal to 1. Okay, so this is the description notation that I talked about this on the video of the basic notations for calculus. Okay, one other class of algebraic functions is just rational functions. So rational functions, what are that? Some function like this. So f of x equals to a fraction. On top I have a polynomial, on the bottom I have polynomial. So p of x and q of x are both polynomials. Okay, as a note, domain of this function, so domain is all x such that denominator is not equal to 0. Okay, as an example of this, let's say our function f of x is f of x equals to x squared plus 3x minus 1 divided by x squared minus 9. Okay, what is the domain? So the domain of this function is all x such that, this is my notation for such that, x squared minus 9 is not equal to 0. Basically, x squared is not equal to 9, and basically when x squared is equal to 9, then x can be plus or minus 3, you know that. But x cannot be equal to plus or minus 3, so the domain would be all real numbers such that x is not equal to 3 and x is not equal to negative 3. Okay, good. So rational functions are very important. That's why I have just a separate place for them in the algebraic function. On the next video, we're gonna talk about transcendental functions.